Hello, my name is Abhishek. Welcome to the journey into the world of high performance computing, which often referred as HPC. So, this is the table of content which we are going to study today. So, first, we will deep dive into the history of HPC, then understand its components, and we take a closer look at PARAM Shivay architecture. We will also guide you how to obtain a user account and how to access PARAM Shivay for your computational lead. Let's begin. The first thing is, what is HPC? So HPC stands for High Performance Computing. It refers to the use of powerful computing system and techniques, and its purpose is to solve complex computational problems at a significantly faster speed than conventional computers. So the next question arises, why do we need HPC? So to solve large, complex problem that would be too time consuming or expensive to solve on a single computer, for that we require HPC. And the first one is innovation. HPC drives innovation across nearly every industry. It is the force behind groundbreaking scientific discoveries that improve the quality of life for people around the world. As our ability to collect big data increases, the need to be able to analyze the data also increases. This is an area where HPC can be most useful tool. And there are many such areas which are there. Reduce physical testing. So I will give you one example where HPC can be useful. So HPC can be used to create simulation which eliminate the need for physical test. For example, when we test an automotive accident, it is much easier and less expensive to generate a simulation than it to perform a crash test. Then, what is the benefit of HPC? So, high performance computing is a powerful tool that can be used to solve complex problems in a variety of industries. HPC systems are typically much faster and more powerful than traditional computers, which allow them to solve complex problems that would be impossible or impractical to solve on a single machine. So these are the four parameters where HPC can be benefited. The first one is speed. HPC can solve problems that would take years to solve on a single computer or desktop computer in a matter of hour or minute. This makes it possible to tackle complex problems that were once out of reach, such as simulating the climate or designing of new drugs. Accuracy. HPC can provide more accurate results than traditional computing methods. This is because HPC system can use more powerful processor and more memory to perform calculation. This is important for tasks where even a small error can have serious consequences, such as predicting the weather or designing nuclear reactor. The third one is scalability. HPC system can be scaled up to handle even large problem as needed. This means that HPC can be used to solve problem of all sizes, from a small research project to massive industrial application. The fourth one is cost effectiveness. HPC can be more cost effective than traditional computing method for solving large problems. This is because HPC system can perform calculation much faster than traditional computer, which can save time and money. Now let's see history of an HPC. So in this presentation, we will going to explore the history of HPC and its evolution. So the first thing came is mainframe and supercomputer. In the 1960s and 1970s, mainframe and supercomputer became more popular. These machines could handle large amount of data and were used for scientific research and military application. The Cray-1 was one of the first supercomputer which was known for its speed. Then the second thing is parallel computing. In the 1980s and 1990s, parallel computing became more common. This involved connecting multiple processors together to work on a single problem simultaneously. This greatly increased computing speed and led to the development of cluster and grids. And the third one came modern HPC, that is today's HPC, is used in a variety of fields like drug discovery and financial modeling. Modern supercomputers can perform trillions of calculations per second and have massive amount of storage capacity. Cloud computing and quantum computing are also emerging areas of HPC. Then the HPC has come a long way since the early days of computing. The development of faster and more powerful computer has revolutionized fields such as science, engineering, and finance. As technology continues to advance, it will be exciting to see what new application HPC will enable. Let's see the component of HPC. So HPC solution have mainly three components, that is compute, network, and storage. Let's see one by one in detail. Com- Compute node are the individual computational unit with a high performance computing HPC cluster. They are responsible for performing the high speed processing and executing parallel computing tasks that make HPC cluster so powerful. Compute nodes are typically equipped with powerful processor, large amount of memory and high-speed storage. They are also often connected to a high-speed network that allow them to communicate with each other efficiently. In addition to compute node, HPC cluster may also include accelerator nodes. Accelerator node is also known as GPU node. Accelerator nodes are a specialized compute node that are equipped with specialized hardware like GPUs. They can accelerate certain type of computing tasks. Then network. So the interconnect is the element which are responsible for connecting and facilitating communication between compute node within HPC cluster. It is essential for allowing the compute node to work together to solve complex problems. And how do we connect these thousands of nodes? It is the element which are responsible for connecting and facilitating the communication between compute node within HPC cluster. For this, we use network topology. So there are some network topology which are used in HPC cluster one by one. So in HPC cluster, it is important to achieve low latency and high bandwidth between the compute node. This is because HPC application often require the compute node to communicate with each other frequently. One way to achieve low latency and high bandwidth is to use network topology, where the network node interconnect via one or more network switches. This type of topology is known as switch network. Switch network offer a number of advantages over the other type of network, such as bus or ring network. Switch network provide a dedicated path between each pair of node, which reduce latency and improve bandwidth. Additionally, switch network are more scalable than other type of network, meaning that they can be easily extended to include more nodes. So this figure, you are seeing some network topology which are used in HPC cluster. Let's see one by one. In short, fat tree. The fat tree topology is a hierarchical topology that is well suited for HPC cluster. It provides a high level of scalability and redundancy. Torus. The torus topology is a mesh topology in which the nodes are arranged in a grid. It is also well suited for HPC cluster and provide a high degree of scalability and redundancy. Dragonfly. The dragonfly topology is a hybrid topology that combines elements of the fat tree and torus topology. It is designed to provide a high level of scalability and performance. Hypercube. The hypercube topology is a mesh topology in which each node is connected to a fixed number of other nodes. It is not as commonly used in HPC cluster as other topology, but it can be used for certain type of application. So the choice of network topology for an HPC cluster depend on number of factors, which include the specific application that will be running on the HPC cluster, the budget, and the required performance and scalability characteristic. Now let's see some networking technology. So InfiniBand and IPMI are the two networking technologies that are commonly used in HPC cluster. InfiniBand. InfiniBand is a high-performance interconnect that is designed specifically for HPC and other high-performance computing application. It can provide very high bandwidth and low latency communication between compute node. Ethernet, you all know about Ethernet. IPMI. IPMI is a hardware solution for controlling and managing server. It provides a way to remotely monitor and control server even if they are powered off or became unresponsive. We are going to see the storage system. So it is the technology and infrastructure which are used to store and manage large amount of data in HPC. So I'm going to tell you some terms which are used in storage system. That is parallel file system. Parallel file systems are designed to provide high performance and scalability for accessing large files. Parallel file systems typically use a distributed architecture, which means that the distributed data can use across multiple servers. This allows them to provide high performance for concurrent access to large files. In HPC, we use high speed solid state drive and high performance hard disk drive. This device can provide high throughput and low latency for accessing data. Then high speed networking is also used in, in HPC. HPC storage system typically use high speed networking to connect the storage devices to compute node. This allows for fast data transfer between the compute node and the storage system. Now let's see what is the major difference between the storage in desktop versus in our HPC. So most HPC storage solutions are file-based with POSIX support. This means that they use a standard file system format that is compatible with most operating system and application. This make it easy to move data between HPC systems and other type of systems. Then our data storage, that is our desktop storage, such as the storage of desktop computer is typically also file-based with POSIX support. However, there are some important difference between HPC storage and our desktop storage. HPC storage is designed for high performance and scalability. This means that it can support a large number of concurrent user and application accessing large file without sacrificing performance. HPC storage system also typically use high performance storage devices such as SSDs and high performance hard disk drive to provide throughput with low latency of accessing data. Then our desktop storage is not designed for the same level of performance and scalability as like HPC storage. It is typically less expensive than HPC storage, but it may not be able to meet the demand of HPC application. Another important difference between HPC storage and general purpose storage is the way the data has been accessed. HPC storage system typically use a parallel file system to provide high performance for concurrent access to large file. Parallel file system distribute data across multiple servers, which allow multiple users and applications to access the data simultaneously without sacrificing performance. Whereas then the desktop storage system, it typically do not use parallel file system. This means that the performance may be degraded if multiple user or application are trying to access the same file or same data at the same time. Now we will going to see of an HPC. So in this diagram, we are seeing the architecture of our PARAM Shivay. So the first one is firewall. The firewall is a network security devices that protect the HPC system from unauthorized access. It only allows traffic to and from the HPC system that has been explicitly allowed. Then login node. The login node is the first node that user interact when they log in. When they submit a job or to transfer or and do anything they have to do with the login node. The user can use the login node to check the status of their job. They compile the application, transfer the file from the HPC system to the local machine, and use other HPC tools and resources. Then the next came the compute node. The compute node are the node where the user's jobs are executed. The compute node are equipped with powerful processor and memory, and they are interconnected with a high-speed network. So Param Shivay has a total of 224 nodes, which include 192 CPU-only node, 20 high memory compute node, and 11 accelerated node. CPU-only node. The CPU node are equipped with Intel Xeon processor, which have 20 core each. The CPU node also have 192 GB of memories each. Then the next one came compute node with high memory, which is also known as HM node. The high memory compute node are equipped with Intel Xeon processor with 768 GB of memory. Then there it came GPU node, that is also known as accelerated node. So the GPU node are equipped with Intel Xeon processor with two NVIDIA Tesla V100 GPUs on each node. After that, there are three service node, two master node, one primary storage, and there is a secondary communication are there in between all these things. Let's see what are the types of nodes which are available in our HPC system. The first one is head or master node. Head or master node are responsible for managing the HPC cluster. They typically run the cluster, scheduler, and other management software. Then it came login node. Login node are the node that user interact with when they submit job to the HPC cluster. User can use the login node to check the status of their jobs, transfer file from the HPC cluster to the local machine, and use other HPC tools and resources. Compute and GPU node. Compute and GPU node are the node where user jobs are executed. Compute nodes are equipped with powerful processor and memory, while GPU nodes are equipped with additional GPUs to accelerate certain type of communication. Management node. Management nodes are used to manage the HPC cluster hardware and software. They typically run monitoring software and other tools for managing the cluster. Switches. Switches are used to connect the different nodes in the HPC cluster. They allow the node to communicate with each other and to access the HPC cluster storage system. Then came firewall. Firewall protect the HPC cluster from unauthorized access. It only allows traffic to and from the HPC cluster that has been explicitly allowed. Let's see specification of our PARAM Shivay system. So this is the system specification where the first one you are able to see in this diagram is theoretical peak floating point performance, that is R peak. So what does it mean? So the theoretical peak floating point performance, that is R peak of a computer system, is the maximum number of floating point operation that the system can perform in 1 second. It is calculated by multiplying the number of core in the system by the clock speed of each core by the number of floating point operation that each core can perform in one cycle. In this case of Param Shivay, the theoretical peak floating point performance is 837 teraflops. This means that the system can theoretically perform 837 trillion floating point operation per second. The second one is sustained performance. It is denoted by Rmax. It is the average floating point performance of a computer system over a period of time. It typically a few minutes to an hour. It is more realistic measure of the performance of a computer system than theoretical peak performance, which is rarely achieved in practice. In case of Param Shivay, the sustained performance is 425 teraflops for CPU only node and 100 teraflops for GPU node. This means that the system can average 425 trillion floating point operation per second for CPU only node and 100 trillion floating point operation per second for GPU node over a period of time. The sustained performance of a computer system is affected by number of factors, including the type of application which is being run, the amount of memory is available, and the efficiency of the system software. So the basic specification of the compute node, which are you see here in this diagram, is we have two Intel Skylake processor, and each processor is of 20 cores, and its clock speed is 2.4 gigahertz. And there is 192 GB of memory in each node, which have a 480 GB of SSD in it. So we see that we have total masters, in addition of master service and login node, we have total 10 node are there, and in which 4 node are for the login node. Then the CPU only compute node, that is the node which have only CPU, is 192 node are there, and in each node we have 192 GB of memory. Then the second node came HM node, which is known as high memory node. So there we have 20 HM node. In each HM node, we have 768 GB of memory. So HM node is used for the application which require high memory. So for that application, we use HM node. GPU compute node, that is GPU node. So we have a total of 11 GPU node, and in each GPU node we have two GPUs, which is of NVIDIA V100 card, and altogether the total memory is 54.3 terabyte. And for the interconnect between all the node, we use Mellanox InfiniBand interconnect, and the primary storage is Lustre based primary storage, which is of 750 terabyte and with have a write speed of 25 GB per second. So if we see the specification of our CPU, HM and GPU node, this is we have 192 GB of 192 node, and each node have 192 GB memory, and you know that in each node we have two CPUs and each CPU is of 20 cores. So total 40 core is in one node. So total if we multiply with 192 node we got 7680 core CPU. Then the compute R peak performance is 589 teraflops for the CPU only compute node. And similarly, we have high memory node. The only thing changes is in the high memory is the your your memory. That is, we in the CPU only node we have 192 GB of memory, and here in the high memory node we have 768 GB of memory. The third one is GPU compute node. So we have 11 GPU node, and each GPU node there is a two interprocessor are there, and 192 GB memory is there with 480 GB of SSD, and in addition to it we have two NVIDIA V100 accelerator card, that is GPU card. Now see the software stack. So to harness the power of an HPC or any computer hardware, we need a software. So this is the software stack which we have used in our HPC cluster. So the first layer is operating system OS. So we have used Linux CentOS 7. So in your mind, one question will be arises why we have used Linux operating system. So the first one is open source. Linux is an open source operating system, which means that it is free to use and modify. This make it a good choice for HPC cluster, which often need to be customized to meet the specific need for the user. Additionally, the open source nature of Linux allow user to inspect and optimize the kernel code for a specific application. Then the second one came high performance. Linux is a high performance operating system that can provide the performance that HPC cluster needed. Linux is also designed to be scalable, meaning that it can support large number of nodes and users. The third one is broad hardware support. Linux is supported on a wide range of hardware platforms, from a small cluster with a few nodes to large cluster with thousands of nodes. This make it a good choice for HPC cluster, which often need to be built using a variety of hardware component. Then the fourth one is extensive software ecosystem. Linux has a large and active software ecosystem, which means that there is a wide range of software which are available for Linux, including HPC application, compilers, libraries, and tools. So this make it easy to find the software that is needed to run HPC application on Linux. Then in the first layer only, the drivers we have there. So we have three drivers: network driver, storage driver, or CUDA drivers, which is also known as GPU drivers. So network drivers are software programs that allow a computer to communicate with other device over a network. They are essential for connecting to the internet, LAN, and other type of network. Storage drivers are software programs that allow a computer to communicate with its storage devices, such as hard disk drive, solid state drive, and optical drive. They are essential for reading and writing data to the storage devices. Then the third one is CUDA drivers. CUDA drivers are software programs that allow a computer to communicate with its GPU. The GPU is a specialized processor that is used to accelerate graphic processing and other type of computation. All three of these type of drivers are important for the proper operation of a computer system. Without them, the computer would not be able to communicate with its network, storage devices, or GPU. The second layer is middleware application and management layer. So in the second layer of HPC software stack is the middleware layer. The middleware layer, it sits between the OS and the application, and it provides a number of services to the application such as file system, resource management, and cluster monitoring. So let's go one by one. File system. So in the file system, we have multiple file systems like NFS, Lustre, GPFS, XFS. So NFS, Network File System. It is a distributed file system that allows users to access file on remote server as if they were in a local machine. Lustre, Lustre is a parallel file system that is designed for high performance and scalability. It is often used in a PC cluster to store and manage large amount of data. XFS. XFS is a journaling file system that is designed for high performance and scalability. It is often used in HPC cluster to store and manage operating system file and application data. Then GPFS, General Parallel File System. It is a parallel file system that is designed for high performance and scalability. It is often used in HPC cluster to store and manage large amount of data. Then provisioning came. The middleware layer include a number of provisioning tools that can be used to deploy and manage the HPC cluster. So in our HPC cluster, we have used one common provisioning tool, that is OpenHPC. It means Open High Performance Computing. OpenHPC is a free and open source software that include a number of tools for deploying and managing HPC cluster. Then the third one came resource management, scheduling and accounting. So the resource management system is used to schedule the account or for jobs on the HPC system. One common resource management system is Slum. Slum is a free and open source resource management system that is designed for HPC cluster. Slum accounting. Slum accounting is a component of Slum that provide accounting information for jobs that are run on the HPC cluster. This information can be used to track resource uses and to bill user for their uses. Then the third one came cluster monitoring tool. The cluster monitoring tool is used to monitor the health and status of the HPC cluster. One common cluster monitoring tool is Ganglia. Ganglia is a free and open source cluster monitoring tool that provide a variety of features for monitoring the HPC cluster. Nagios. Nagios is another popular open source cluster monitoring tool which are used in HPC. It provides comprehensive monitoring and alerting capabilities for HPC cluster. For ticket, we use OS Ticket for help desk. OS Ticket is an open source web-based support ticket system that can be used to manage support ticket for the HPC cluster. The third layer of the software stack is HPC programming tool. This layer provides a number of tools and libraries that can be used to develop and optimize HPC application. Communication libraries. So, communication libraries are used to enable HPC application to communicate with each other across multiple nodes of the HPC cluster. Some common communication libraries are used in HPC include Intel MPI. Intel MPI is a high-performance MPI library that is developed and supported by Intel. OpenMPI. OpenMPI is a free and open source MPI library that is supported by a large community of user and developer. MBA PIC2. MBA PIC2 is a high performance MPI library that is developed and supported by the MBA PIC team at the University of Tennessee. PGS, Partition Global Address Space, is a programming model that allows HPC application to access global memory across multiple nodes of the HPC cluster. Some common PGS include Unified Parallel C (UPC) and Global Address GA. Then the second one came development tool. Development tools are used to develop and compile HPC application. Some common development tools which are used in HPC are Intel Cluster Studio, GNU Compiler, or CUDA Toolkit. Intel Cluster Studio is a development tool that is designed for HPC development. It includes a compiler, debugger, performance analyzer, and other tools. Then the second one came GNU Compiler, that is GCC. GCC is a free and open source compiler that can be used to compile HPC application. Then it came CUDA toolkit. The CUDA toolkit is a development tool that is designed for developing GPU accelerated application. It includes a compiler, libraries, and other tools. Then the third one came application libraries. Application libraries are the libraries that provide pre-written function and routine that can be used by HPC application. Some common application libraries which are used in HPC include NetCDF, Math Library, GSL, and Python libraries. NetCDF. NetCDF is a library that is used to store and manage scientific data. Math libraries. Math libraries are libraries that provide pre-written function and routine for performing common mathematical operation. Some common math libraries used in HPC include Intel Math Kernel Libraries (MKL) and GNU Scientific Library that is GSL. Python libraries. Python libraries are the libraries that provide pre-written function and routine for performing common tasks in Python. Some common Python libraries which are used in HPC include NumPy, SciPy, and Matplotlib, and many others. Then the fourth one came visualization tool. Visualization tool are used to visualize the result of HPC simulation. Some common visualization tool used in HPC are ParaView, VMD, Ferret. ParaView is a free and open source visualization tool that can be used to visualize scientific data. VMD is a free and open source visualization tool that is often used to visualize molecular dynamics simulation. Ferret. Ferret is a free and open source visualization tool that is often used to visualize the climate data. The next one came is performance monitoring tool. Performance monitoring tools are used to monitor the performance of HPC application. Some common performance monitoring tools are HPCC, that is High Performance Computing Challenge. It is a performance monitoring tool that is developed and supported by Lawrence Livermore National Laboratory. IMB. IMB is known for Intel MPI benchmark. It is a benchmark that can be used to measure the performance of MPI implementation. IOR, that is input-output tester. It is a benchmark that can be used to measure the performance of file system. HPCG. HPCG benchmark is a benchmark that can be used to measure the performance of HPC system for solving system of linear equation. And inside there is a CDEC component. In the CDEC component, there are CDEC tool, their CREAM is a software, and the Cchaksu is an monitoring tool, and HPC task automation script are some of the script which are used to automate the task, and the cluster checker script which use the whether the cluster is to check the health of any cluster. Then we will see how to get your user account on PARAM Shivay. First, visit the website of IIT-BHU.ac.in. Go to SCC section where you will be able to see the user account creation form. Download this form, fill the form, and after filling the form, submit the form to the SCC admin. When you submit the form, they will create an account and give you a user ID and password. Let's see, when you get a user ID, then how to access Param Shivay. First, we can access using SSH. So open any command prompt, write SSH, your username at the rate the domain name, that is paramshivay.iitbhu.ac.in. Then specify the port number -p with 4422. Then press enter. So if captcha does not appear initially and only password field is there, press enter repeatedly until the captcha becomes visible. Then fill captcha, then fill password, and you will be able to log in the Param Shivay cluster. Then you will be going to land in one of the login node with login node 1, 2, 3, and 4 named as. See the demo time. Thank you. In the next topic, we are going to see about basic Linux command. Thank you.